Lesson 8.5 is going to be talking about polar equations and graphs. So the first thing we're going to look at under this lesson will be called polar coordinate system. So far we have been working on rectangular coordinate system where we have an x coordinate and y coordinate. But now when we move to polar coordinate system is not going to recognize the x and y, but it's going to recognize r and theta. So when we talk about the polar coordinate system, the center of the system is going to be called pole. And then we will have a ray called the polar axis. And we're going to see examples of the polar coordinate system. So rectangular coordinate system is going to use x and y, but the polar coordinates, they will use r and theta. And we must know the relationship between rectangular coordinate system and polar coordinate system. So for rectangular coordinate system, x is always equal to r times cosine of theta, and y is always equal to r times sine of theta. And we have used these on the previous sections before. R squared is always equal to x squared plus y squared, and tangent of theta is always equal to y over x. So what we're going to do is after this introduction part, we're going to actually look at some homework problems, and then let's take a look at our homework questions now. Under this section, for the homework questions, 8.5 homework has total of 11 questions. So the first question is about plotting the points. So for the first problem here, the question comes in 3 parts ABC. So they gave us this polar coordinate, 1, 135 degrees. So R is 1 and angle is 135 degrees. So we're going to have to find the correct answer for this coordinate. So the correct answer is here, C. Let's explain how I got this answer. First, we're going to place the angle 135 degrees. Remember in trigonometry, the angles, they always start from this 0 degree. And then when I start from 0 and go to the counterclockwise direction, I hit the 90-degree angle, but I have to keep further down to this line. So this will be the 135. This is where 135 is located. So this is the pole. And then this is our polar axis. Now, once we take care of where we are going to land on, this will be the line we're going to land on because of the angle. R value is 1. So from the pole, I just need to count 1 circle to plot the point. If R was a 2, I was going to go 2 circles. If R was 3, I was going to land here. If R was 4, I was going to land here. But in this case, 1, 135 degrees. So first we find the 135 degree, and then we count from pole to 1 circle down here to place the point. So this is where 1, 135 is located. Next question is, which of the points below is equivalent to these points? Now, whenever the angle is more than 360, but they are coterminal, but you're keeping the same R value, they will be always the same point. So basically, when the angle is 495, so 495 means we're going to start from the same angle. When I finish my first tour, I am completing my 360 degrees, but for 495, I have to go 135 more. So I'm going to end up on the same line, and R value is still 1, so this is going to show me the exact same point. My other answer for this one was -1, 315 degrees. So if you look at 135 and 315, they add up to 316 degrees. So let's take a look at how I am going to place this point, 315 degrees. So I start from 0. This is 90, this is 180, this is 270. So this line will be the line for 315 degrees. If R was a positive number, I was going to plot this point. But whenever R is a negative number, you just get the reflection of the point, and then you plot the same point as 1, 135 degrees. That's how we get this part of the question down. Now, I am going to find the rectangular coordinate for 1, 135. So let's just show the work for this. So for 1 comma 135 degrees. So this is what I have for the first question, part C. Our polar system has R value is 1, and then the angle is 135 degrees. We want to change this to X and Y value. So X will be equal to R times cosine of theta is the formula we need here. And then in this case, the R value is equal to 1, and then cosine of 135 degrees. So it's 1 times, and cosine of 135 is the same thing as cosine of 45 degrees, but it must be a negative number. So this will be the X value here. Similarly, now we're going to find the Y value of this point. Y will be calculated using the R times sine of theta. R is still 1, but this time we need to calculate it and multiply it by sine of 135. So sine of 135 is positive root 2 over 2. And then when I multiply them, this is what I get for the answer for this question. So when I go back to the homework and then share my homework screen again with you guys, when I share my homework, I will tell them that for 1 comma 135, this is the polar coordinate, is the exact same coordinate as negative root 2 over 2 and comma root 2 over 2 for this problem. Now, if one example is not clear for you, you can click on V1 example button, or if you click on get more example, more help, you can click on a video, you can click on an animation, you can click on a textbook, or you can simply say an example, and then when you click on an example button, they explain you step by step how the answer to these questions can be calculated if my explanation is not enough for you, for number 1. So for number 2, it's a very similar question. It comes in 3 parts again. This time, we want to place negative 3 comma 45 degrees. Now, I'm going to expand this one and see if this can be my right answer. The angle is 45 degrees. So I'm going to start from here, and 45 is this line down here. If the R was positive 3, I was going to count 1, 2, 3 of the circle, and this was going to be my point, right? But because R is a negative 3, I just need the reflection of my point. Whenever the R is a negative number, you get the reflection of the point. So this option A is the correct answer for negative 3 comma 45. So you place the angle first, and then if R is a positive number, you locate the point on the angle line, but if R is a negative number, you get the reflection of your point. Second question is, we're going to find what other one of these 4 points are they going to place in the same location. So for 225 comma 3, so actually it's 3 comma 225. So when I place the angle first, that's 180, so 45 more. So I'm going to be on this line, and the R value is positive 3, so I'm going to be on this original angle. So the first one works. So the first one will give me the exact same thing. For B, angle is 405. Let's see where 405 will be located. So for 405, when I completed one tour, it's 360. So if I go 45 more, so this will be my angle. If R was positive 3, I was going to place this point. But for option B, they gave me the R to be a negative 3, so I need to get the reflection of my location, which is also correct. So B will be also correct coordinate for this location. What about 3 comma 4, 4, 5? I don't have to check this anymore because only negative 3 will satisfy this. For 45, we know that this is not possible when they are both positive. 45 is here and positive 3 is going to get me a point like this. So only A and B will be correct answer for this part. And now we want to convert negative 3 comma 45 for the rectangular coordinate system. So therefore, I am going to share my paper again to show the work for how I perform the conversion. So my polar coordinate is negative 3 comma 45 degrees. And then we want to convert this to rectangular coordinate system. To find the x value, we need R times cosine of 45 degrees. So it's negative 3 times, and cosine 45 is root 2 over 2. So it's negative 3 root 2 over 2. For the y value, I need -3 times sine 45, which is going to give me the exact same thing as my x value. So when we go to the homework again, when we go to the homework again, I will tell them that the first value in the rectangular coordinate system is -3 radical 2 over 2, comma, and then again, -3 radical 2 over 2, and then I will close this and check my answer, and then it'll be correct for this question. So since this is the same type, I will let you explore this on your own. Now, let's take a look at question 4. For question 4, we have this point given 9, 120 degree, and we need to locate the quadrant for this. If we locate the angle first, 120 degrees is in the second quadrant, and its R value is positive, so we're not going to get reflection. So we know that this is going to be still second quadrant point because of the angle. Very similar question. Angle is 45 degrees, which is in the quadrant 1, and R value is positive, so I get to stay in quadrant 1 since I don't have to take the reflection of the point. So similar example, but now the angle is negative 145, angle is negative 45. So instead of going counterclockwise direction, this time I need to go clockwise direction. So negative 45 is actually located in quadrant 4. Since R value is positive, I get to stay in quadrant 4 for this question. For the next one, angle is 242. So you know that 242 is located in quadrant 3, and its R value is positive. So I get to stay in quadrant 3 for this question. For question 8 now, we are going to actually need some space to show work here. We have this rectangular equation, x minus y is equal to 23. We're going to convert this rectangular equation to a polar equation, and we're going to sketch its graph. So this question comes in parts. So first, I have to change this rectangular equation to polar form. Polar form means x and y has to disappear, and I need to get all equation in terms of r and theta. So let's just share our blank page for this and write down the question. We want to convert x minus y equals 23 to the polar system. Instead of x, I can write r times cosine of theta. Instead of y, I can write r times sine of theta. And this can be written as 23. So technically, this answer is right. There is no more x and y. But let's see what happens when I place this question to the my answer to my MATLAB. So when I come back to my MATLAB, and if I try to tell them that the polar form instead of x, we just write r times cosine of theta. And I think instead of theta, I'm just gonna grab the sign from the bottom minus r times sine of theta equals 23. This is how we can convert this rectangular equation to polar. It accepts it, so I don't have to go through a simplification process. Now for the graph, they graphed it on polar form, but according to the rectangular system, I know that this is a line, and then if you organize it, this is a line, but it is decreasing. So because if you put it in slope-intercept form, y will be equal to x minus y is equal to 23. Its x-intercept is 23. Its y-intercept is 23. So it's going to be a graph like this in terms of rectangular coordinate system. And then see, if I just use my rectangular coordinate system and marking this answer did not work for me. So if you click on this example button now, and then they tell you how to change this first part, And then they even organize it more than I did for this question. But since homework doesn't require it, you don't have to do it. For the graph though, once they put the equation in the format of r is equal to 25 over cosine theta minus sine theta, they are using some simple theta values, like angles from 0 to 90 degree, and evaluating the cosine value for that angle and sine value for that angle, so they can plug into the equation to find the output for each angle. So when angle is 0, the corresponding r value is 25. So in this polar coordinate system, r matches with 25. When the angle is 30, you need to get your r value to be 62.5. So angle 30 gives you 62.5. Angle 60 is a negative r value. So you're going to be on the other side. You're going to have the reflection. So using all this example, it gives you this graph for this question. And I'm okay if you actually use a Desmos calculator to produce the graph of these polar systems on the homework. For question 9, so you're going to do the same thing, replace the x with r cos theta, replace the y with r sin theta, and then square both of them. Let's just do this one, and then because this is going to actually produce something familiar that we know. So for this question, the given problem to us for number 9 is x squared plus y squared is equal to 9. If you guys remember this from college algebra, this equation belongs to a circle whose center is at 0, 0, and the radius is 3. So x squared plus y squared equals 9. If people took this college algebra class, they know that this will be a graph of the circle. But let's convert x squared plus y squared equals 9 to the polar system. For polar system, x will be replaced with r times cos theta, and then we're going to square this. For y, I need to plug in r times sine theta, and I need to square this. And I'm going to make them equal to a 9. When I square this, I get r squared cosine squared theta. This one is r squared sine squared theta. And then this is a 9. R squared is a common factor, so I'm going to factor this out. All of these steps are very important. And then I will make this equal to a 9. In any trigonometric class, sine squared plus cosine squared of any angle is always equal to a 1. So we get r squared is equal to 9. When we take the square root of each side, r equals 3 is the polar form of this. So this means whenever I have r equals 3 in polar equation, I must also know that this is going to give me a circle. So here, polar form of the rectangular equation. All right. So maybe if they don't accept this answer, they want me to simply give them r squared is equal to 9. Okay, we use these relationships and we plug them in, and then we got the answer. But let's just final check to see the answer. Oh, we were right about r equals 3, our original answer, but we had to give them that equation can be r equals 3 or r equals negative 3, since when you take the square root of 9, either it gives you a 3 or negative 3. That's a good example to learn our mistakes. And r equals 3 is just a circle whose r value is equal to 3. So when I look at this one, this is a circle, but here, I'm not so sure if it is a circle where r value is equal to 3. But when I open this one, this is a circle for r equals 3. The center of the circle will be exactly at the pole. It's not going to be on the y-axis. It's not going to be on the x-axis. It's going to be exactly at the pole. That's where the center will be. And then you're going to count 3 units to the either direction. So 1, 2, 3. This will be the graph for r equals 3 in polar system for this question. And then for question 10, it's a very similar question. We already know that this will be a circle. And then the equations we're going to give them is r equals 9 and r equals -9 when you do the work. And it will give you the equation of a circle. For this one, now you want to convert it to a rectangular equation. So let's just do this one quickly. It's the opposite. So we have this time r is equal to -2 sine of theta, and we want to convert this to a rectangular coordinate system. So therefore, I will multiply each side by r so that r squared will be replaced by x squared plus y squared. And then r sine theta is always equal to the y, and this is a -2y. So I am going to go ahead and plug this into the MyMATLAB without further simplification to see if they just accept this. Although it's possible to simplify it further down, I'm just going to write x squared plus y squared is equal to -2y is what we need here. See, they didn't like this. That means they probably want us to simplify this further. So I will just move plus 2y to the first side and then set my equation to a 0 and then check my answer. Okay, your answer is equal to the correct answer, but it's not in the correct form. Be sure to read any instructions given in the problem. If there are no special instructions, make sure your answer is fully simplified. So we have everything right. Type an equation, type your answer in standard form. And when they say they want the answer in standard form, I know that here I can add 1 to make this a perfect square trinomial. So here I can write it as y plus 1 to the second power. And then that makes my 0 to change to a 1. This is because of the circle equations. Now it accepts this. So they want you to really convert this to the best form of the circle standard form. This is a circle whose center is at 0, -1, and its radius is at 1. So we need a circle whose center is at 0, -1. So when I check the circle, for this circle, the center is at 0, -1, and its radius is 1. So the answer will be C for this question, and that's how you do 8.5.